Welcome to Fisher Maths. I'm dealing with integration today. Integration. Integration is also known as anti-differentiation. Integration is also known as anti-differentiation. In an integration, if I have a value y equals to axn, this is the differentiating this, I will have dy over dx equals to multiply the power, the index, with the coefficient, the differential coefficient. I'm going to have an xn minus 1. Now, because it's if I want to get the integration, which is an anti-differentiation, I will say y is equals, then this must be accompanied with plus c, where a is a coefficient, is a coefficient, c is the constant. So in integrate 3x squared. This can also be interpreted to be integral of 3x squared, which must also be accompanied with dx. So as soon as it is integrated, this is a sign of an integral will disappear as soon as it's integrated. So using the formula, we're going to have it to be 3x2 plus 1 divided by 2 plus 1 plus c. And so then we have 3x squared 3 raised to power 3, because 2 plus 1 3 divided by 3 plus c. C must be there every time you integrate. So then we have this can cancel off this, and this we have s cubed plus c as the value of this integration of 3s squared. Of course, I can reverse this using differentiation. I need to come back to this. That's why the integration is anti-differentiation. So if I wish to return it back to that, I will differentiate this. Let me give you an example. Now let's differentiate it so that we can get back to that. So we have, if I say y is equals to s cubed, then differentiating that will give dy over dx will give me, multiply this with the coefficient, which is 3, then x, remember that I said we're going to use minus 1. So minus 1, that will give me 3s squared. You see, it comes back to the value where we're coming from. So the differentiation, the anti-differentiation. I hope that is clear. Thank you for listening. Goodbye. This is Fisher Maths.